My name is Kim Nilsson. I'm a CEO and co-founder of Pivigo, a data science marketplace where we connect companies to our global community of freelancing data scientists to work on projects. In this presentation, I will talk about how we built a recommendation system for Mindful Chef, and specifically how we help them reduce churn with this model. Joining me on the talk will be Grieg, Gran, COO and co-founder of Mindful Chef. Good afternoon, everyone, and welcome to this session where we will talk about how we explored in new ways and new novel ways how to recommend recipes based on something we call adventurousness. My name is Kim Nilsson. I'm the chair and co-founder of Pivigo, and I'm very proud to host this session together with Rob.
Hi, good afternoon, everyone. I'm Rob, one of the co-founders of Mindful Chef. Mindful Chef is a UK-based business, and we're delighted to be working with Pivigo on some of our data science projects.
So let's start with introducing our organizations in a bit more detail so you know who we are and why we have embarked on these projects together. So Pivigo is a data science marketplace and training provider. We help organizations to innovate with data by connecting them to our global community of freelance data scientists. To date, we have completed over 250 projects with 150 different partners, and typical projects include things such as optimization, predictive maintenance, and recommendation systems, such as the projects we are describing here.
And Mindful Chef is a healthy food company, so we deliver all the ingredients that you need to make healthy evening meals at home. We launched in 2015. Since then, we've delivered many millions of recipes across the country. And it was about a year ago, just over a year ago, that we thought we could probably do a far better job with all the data that we collected around people's interests to do a better job with data science. And that's when we gave Kim and her and Pivigo a call.
And after that initial conversation, we agreed to work together on a very specific feature that Pivigo offers, which is the S2DS, or Science to Data Science program. And so, in fact, the two projects that we are presenting here were both completed in this format. In brief, S2DS is a 5-week full-time bootcamp. We target academics who want to transition from academic roles into industry as data scientists. And for the 5 weeks, they work in teams of about 5 on a real data science project, such as what we describe here. And they deliver that outcome to the company. They gain skills and commercial experience that they can use to then start their new data science careers. And of course, for companies like Mindful Chef, it's an opportunity to dip their toe in the water, try something very innovative around data science, and potentially even hire from it. And so these projects were completed in the S2DS program.
Perfect. So this is the challenge that we set the students in the first project that we went to them. We said every week, we sort of explained the service to them. We said every single week we have 16 recipes for our customers to choose from. And currently, as a subscription service, we allocate those recipes to the customers. Currently, or back then, we used a very basic recommender, which was really driven by customers' individual food preferences. So customers would say, you know, I would like to only see vegan meals, or I don't eat pork, so don't show me those recipes. And so we had just a static lists with a few groupings of customers, and that's what we showed everyone. And really, we wanted to be able to use the data of their past purchase history to build up an idea of how we could personalize the service to each of our customers. And the term that we used was kind of building a digital waiter to allow to give recommendations to each customer. And the final challenge that we set the students for project one was to actually deliver us an API that we could use in production very quickly. So there was also the data science analytical part of the project, but then also bringing it to life so we could put real life customer data through it and test and validate their learnings.
And indeed, there were challenges for this team to start to dig into this problem. Now, one of the key problems here is what's called the cold start problem. These 16 recipes that were recommended every week, many of them are new recipes every week. There is, of course, a history of recipes that come back, but there are also new recipes available every week. And so how can you possibly start to rate those new menu items every week? Also, these are very high dimensional data. So you have a title, but you also have ingredients, you have lists of steps and instructions of how to make these dishes. And so looking at all those features that are possible for each dish, that could be up 10,000 features or more. And if you combine that together with the customer and the knowledge we have about the customer and their preferences, we are talking about a feature space that could be 100,000 strong. So that is a big problem. And finally, we had the problem of what the team called the Big Mac problem, which is that we tend to pick the same thing again and again. We're quite comfortable picking certain food, but maybe does that mean that we should recommend just that sort of food, or does that mean we should actually challenge their tastes a little bit and try something new? But the first thing they had to tackle was to try to get this into a lower dimensional space. And so what the team came up with were 2 dimensions to start to work with. They defined what they called a meatiness vector and a soupiness vector. And you can start to intuitively see that things like vegetable soup and chicken soup are at opposite ends on the meatiness scale, but around the same on soupiness. Whereas lamb chop and beef soup are both very meaty dishes, but quite different in terms of the soupiness factor. And so this was the first attempt at getting that dimensionality into something lower dimensional that we could actually work with. And now the question is, with the cold start problem, could we also solve that with this? Well, imagine we now create 2 new recipes and we want to get them into this plot. You can start to, of course, put them on the same dimension. Does it include meat or not? How soupy is it? How wet is the dish, so to say? And therefore, this is a way to also now start to solve the cold start problem. And then, of course, that final problem with the Big Mac problem, we have to start to think how we can actually map recipes and map the journeys of our customers in this space. And what we can start to look at is, how do they tend to move around within this space? Do they tend to make very small steps that are incremental within a very closed area within this graph? Or are they happy to do quite large and random jumps in many different directions? And so this is something that the team felt could solve all of the 3 problems I mentioned around cold start. Well, we can map new recipes onto these dimensions. It's a lower dimensional space with fewer vectors and fewer features to take into account. And we can start to look at how adventurous, how curious each of these customer is. So looking at what features are actually important here to the customer. The team looked at a lot of parameters, and in this graph that you see here, delta 1 and delta 2 are the actual distances in steps within this graph that a customer would make between the first choice and the second choice, between their first order and their second order. And as you can see, those are by far the most important features in terms of guessing where the customer is going next. What's called curiosity in this graph is actually a combination of those 2. So the actual distance between the first order and the second order as a total within this space. And so these 3, which all sort of indicate how adventurous, how curious, how happy someone is to try something new, were by far the most important features to decide what a customer wants next, which may be surprising if you think that things like number of carbs, number of calories, whether it's vegan or not, actually have a much lower significance. And so that was the first really interesting finding by the team around this. They now could use these parameters to put them into actual machine learning models to try to see, can we recommend better than what is before? And as Rob has explained, Mindful Chef had a rule-based set of recommendations already before we came into the picture, and that already did better, 15% better than a completely random baseline, where you just give them absolutely random recipes and hope that one of them is interesting to the customer. So the Mindful Chef system already did better than that by 15%. But of course, the target was to do even better than that. Now, the team tried 3 different algorithms. We have logistical regressions, neural networks, and random forest. And as you can see here, all 3 of them were able to outperform the static rules-based system that was in place with Mindful Chef. And in fact, with random forest, it was 3 times better, more or less, than what was existing before. The Random Forest Plus, as it's called in this graph, was a version where they actually added extra features into the model, but they decided at the time to actually go back and use the original Random Forest model, because as Rob mentioned, you have to remember that this was actually packaged up into a solution that was an API, it was sitting within a Docker container, and it was a plug and play model for Mindful Chef to immediately start sifting through data, sending data to it about customers, about recipes, and immediately getting recommendations out. And all of this was done in 5 weeks. And that's why they were not able to implement the very best model they had, but they saw that it is possible to push this even further.
Yeah, I mean, as the client on the project, we were absolutely thrilled with the outcome, and to be honest, really surprised that it was this sort of new metric that we hadn't considered before about how adventurous a customer is in terms of how do they jump around the recipes that we offer each week. That we found like super interesting and really fascinating, and also to be able to look back at all the historical choices that the customers had made and see this like big improvement in terms of how we could get better at recommending recipes that they would like in any given week. And I guess when we started to think about how does that translate into commercial impact for the business, I think, you know, our sort of idea was that if we could recommend better recipes to the customers, then we would likely improve customer retention and really encourage them to make more purchases, because you only get a limited amount of like people's concentration in any given week. And so if you can capture them with beautiful images of exactly the recipe that they want to eat, and you've used a bit of clever technology in the background to sort of recommend those recipes, then we could sort of drive more purchases and keep people sort of engaged in getting Mindful Chef deliveries. I think then some of the more things that we hadn't really considered was that by putting the same sort of information, like this is your customer base, this is what the model is predicting they would like to eat in any given week, you can actually bring that information back to your chefs and say, customers are really looking for a recipe that sits here in our dimensional space, but there's nothing on offer that week that would capture their interest. And that's sort of like a really interesting, like sort of feedback loop almost of having the model, and that we can like really use it to influence the design of the recipes that we offer and the offering across the thing. And also if we become better at understanding what customers are likely to choose in the future, that can also help us forecast demand better, which is a big challenge in this business of like forward buying, guessing what people are going to want to eat in a few weeks' time, and placing all of the orders for the fresh produce to come in from the farmers. In terms of validating the kind of the commercial, impact of the project, we really looked at one specific thing, which was what we knew about our existing customer behavior. So we knew on any given week that customers who had selected their own recipes, so they'd been into the system, they'd looked at the recipes on offer, and they'd made their selection, had a far lower churn rate on a weekly basis, like attrition rate as it's called in this chart, than the ones who were given the system recommendations, i.e. from our baseline model that we had challenged the data scientists to improve. And so that's somewhere between 7.5% sort of weekly churn for those who hadn't chosen, that dropped down to 4.3 for those who were making active choices in any given week. And so we thought, okay, well, if we can improve the model and make better recommendations, then we could probably make a 30% improvement on this scale. And that really feeds back sort of in real terms to 1.6 more boxes, more deliveries per customer per year, of which the benefit is like very sizable for us to be able to achieve that. And we were like absolutely thrilled with the outcome. And then we started to think about, okay, well, this is brilliant for existing customers where we have really good long-term purchase history. We can feed sort of 10 or so delivery like choices that they've made into our model. Then we have a really good chance at recommending better recipes than we were before. But what do we do for a brand new customer? And how do we, if we don't have any purchase history from them, apart from maybe their very first order that they've just placed, how do we then train our model quicker to make recommendations from day one or week one of them being on the service? And we don't have to wait a couple of months before we can really start to use the model, this data science model to influence how we recommend recipes to them. And so this was like the next problem that we set to the team. We said, can you design something that can educate our model for a new customer, to information to give a new customer that can allow them to benefit from the same fantastic recommendations that we're now making to our long-term customers.
And of course, the team was challenged again, and you have to remember that this was now another S2DS program, so it was another S2DS team. They were not aware of the work that had been done previously, so that was their first challenge, was getting up to speed with what the first team had done. And then, as I mentioned, with that Random Forest Plus model, it was also clear that there was more opportunity, more potential in terms of delving deeper into this idea of the dimensionality, finding the right dimensions, finding potentially clusters of recipes, clusters of data that could help this algorithm work even better. And then on top of that, within 5 weeks, this team of academics had to figure out how to make a web app that worked and could be sent out to real clients in that time. And a constraint was that the game had to be less than 60 seconds to keep the attention of the user. So those were the challenges set, and the team created then 3 games for these customers to try. Now, the first game was a baseline scenario of basically random choice. So this would be the experience if you are the first time user or Mindful Chef. You get shown 5 recipes and you have to pick anywhere, as many as you want, but in this game they were asked to pick between 2 or 5 that they were interested in. And then that was repeated again with random recipes. And this was basically the baseline. We have to do better than this. So this was the baseline scenario in game 1. In game 2, the team then used TF-IDF to see if they could really work more on these vectors, as I mentioned. So trying to turn each recipe into a vector in a space that could now have more than 2 dimensions. Remember, we had meatiness and soupiness in the first go, but now we're saying we can have a slightly higher dimensional space, and we'll just map these onto other parameters per se. And with these vectors, they were then able to do PCA to see which vectors are in a similar area of that graph, in a similar area of that multidimensional space. And the game in that case was specifically to show the customer, or rather to ask the customer first to pick a food group that they were interested in. So this could be things like vegan, chicken, beef, fish. And after selecting that, they would be shown 10 images that were picked within these clusters that they now saw in this vector space, by taking into account also the center point of each cluster, as well as any extreme points within that cluster, to see what they picked. And of course, the idea is that digital weighter that Rob mentioned at the start of this presentation, the idea that you have a smart weighter, a smart system that knows what you like and will recommend you things that are similar, and also in this case, taking into account the feedback that previous customers had made and the ratings they had on each dish. So game 2 was about selecting food group first, then 10 images of which you pick the ones you are interested in, and then repeating that twice. And then in the third game, they went even further in terms of understanding all the information available about each dish. So as I mentioned, we have a title, we have ingredients, we have the number of steps in the recipe, the description, the recipe description itself. There is an enormous amount of information here. And they tried to make use of all of that information, and using LDA and k-means clustering, they identified 4 new clusters here, which they called salads, curries, traditional English dishes, and everything else. And so using this in the third game, they were asked 3 questions. In each one, they were shown images or shown recipes from each of these clusters. They were asked to pick 2 to 8 of them. And based on how the outcome came in terms of the percentage that they picked from each of those clusters, that's then what would be applied on the final recommendation. So picking recommendations that fall roughly within the same ratio that between those clusters as the customers have indicated that they're interested in. Now you have to remember that the idea with this experiment was to test against existing customers. So the idea was to send these games out to customers who we already had data on. So we basically knew what the traditional system, the system that Team 1 had developed, we could compare what the onboarding game came out with to that, and therefore we could also see what is the true recommendation at the end. And so these 3 games were sent out to about 7,000 real customers. They got replies from over 800 in each of the 3 games over just 3 days. And they came up with 2 metrics to try to determine how good actually these onboarding games were. Now, you'll remember we talked about the Delta 1, Delta 2, and in fact, with Delta 1, 2 here, we mean the curiosity parameter that I spoke about earlier. So it's the distance, so to say, in food vector from the first order to the second order. That's what we mean with Delta 1, 2, or the curiosity parameter. And that's one way of seeing, can we find the right curiosity parameter for this particular customer? This team also looked at what they called magnitude, so not taking the whole order and the distance between the 2, but rather looking at every recipe that the customer had chosen, because of course they could choose typically anywhere from 2 to 8 dishes in each order, and so that can make a big difference, whether you're at one end or the other end of that category. But they also then looked at magnitude, so what is the total overall distance in steps between these dishes? And they were then able to do some A/B testing on these models. And this is where it gets very, very interesting. So remember game 1 I mentioned was the baseline scenario of random guess. And of course, you understand that even a random guess will sometimes get things right. And so game 1 did okay on some of these metrics. On the left here, we have the curiosity metric. On the right, the magnitude metric. But what was, of course, fascinating to see and a great outcome for the team was that both game 2 and game 3 outperformed the random game. And it outperformed it quite significantly. So in terms of the curiosity parameter, game 2 outperformed the random game by 6 times, and the game 3 even by 12 times. For the magnitude, for technical reasons, it was not possible to calculate the factor for game 3, but for game 2, that was also clearly 7 times better than the random situation. And so what this shows is that Mindful Chef doesn't have to wait until 10 orders have passed in order to decide or to make good recommendations of what the customer wants next. They can just ask the customer after their first order or around their first order to fill in this game 60 seconds long, and they can already start to make really highly relevant recommendations after that first order, which of course goes back to that customer satisfaction, customer attention, and lowering of churn that Rob has mentioned.
Yeah, our customers were super engaged with this project, and they loved this idea that they were helping some data science students like validate their models and all of the work that they'd gone into on the 5-week project. We ended up collecting about 700 results from real customers for each of the 3 games. And we had like really high response rates in terms of people actually wanting to engage, wanting to understand more, wanting to sort of see the results. So it's like really great from that perspective. And we used customers where we already had lots of purchase history. So the model would work, and then the game would also work, and then we could compare the two against. And I guess by the way, the nature of our service is we always have far more people who are trialing the service and who are new customers than we do who end up spending, lots of time on the service and end up, being the kind of the big commercial drivers of the business. So there are lots of people in this like trialist phase. I mean, so like nearly 60% of our customer base will leave after just a couple of orders. Service isn't for them, or they couldn't find the recipes that they wanted, and so, or they're just giving it a go just because they've heard about it. And so, for us, if we could use an onboarding game to even just nudge one more order out of these new customers, then the commercial impact for the business and the idea that you can sort of bring people on the onboarding journey a little bit better by recommending recipes that they really like actually had quite a big prize at the end of it. So it was another project really that we were really happy with the outcome, and thought like super interesting that this is something that we can gamify the experience for new customers and really make them feel like they're getting a personalized offering after they've played a 60-second game with some really clever maths in the background. To summarize about how across the 2 projects now that we've done, which were a year apart, by the way, we first of all we managed to build, I should say the students managed to build a personalized recommender system that had huge outperformance on our like original rules-based model. They delivered us a productionized like working model that now actually drives recommendations for real customers, and we actually ended up keeping one of the original team on, and he's worked with us throughout the last year, kind of building like additional features into that the first recommender, and also making sure that it actually retrains itself as more and more data gets to sort of to flow into that. And then I guess with the success of the first project, we've now got the building blocks, and we have the onboarding game to bring the functionality of the recommender, which is working really well for existing customers, in order to build up this sort of fake order profile of new customers in less than a minute, I think so, from our perspective, we've had really good, like a really great experience, and it provides a really sort of strong investment case for us to make sort of further investments into data science work, and to sort of understand how it can improve our customer experience going forward. So there's plenty more projects on the horizon, I'm sure. Thank you very much for joining, and now Kim's going to run the Q&A.
Yes, and thank you, Rob. It's been a great collaboration between our two organizations, and I've also been very impressed with how open Mindful Chef has been in terms of embracing this change and embracing this innovation. So let's see if we have any questions. And we have several questions. All right. So while creating this project, have you considered the regional likes or dislikes, and which ecological sources of products were the nearest to the users? Oh, that's an interesting question.
That is a very interesting question. No, not really, is the answer. If you had a keen eye, you might have seen in the factors that were important to drive the model, that household income was in there. That was proxied from the customers' postcodes. So in the UK, there's a thing called the National Deprivation Index. It's a government listed list of all the postcodes in the UK with a number next to them, which kind of looks at deprivation. So it looks into access to healthcare, crime, average household value, education, etc. And it gives a number. It's a really good statistical tool for postcode profiling. It appeared fairly low down the list. That's the only thing that we looked at in terms of geography. We didn't look at whether people from the north of England, eat more of one thing than from the south. But maybe that's something to consider for a future enhancement to the model.
It would certainly be interesting to just look at the data and see if there's something there. I mean, that would be fascinating in itself. And to be clear, in terms of ecological sources of product nearest to the user, am I right in that Mindful Chef is only in the UK at the moment?
Yeah, exactly. So we're a UK only service.
Yeah, and so produce wouldn't have to travel very far anyway.
Exactly.
But again, if you have global expansion plans, then that's something to consider. Do you recommend not only the recipes that the user would like, but also the ones that would be beneficial for losing or gaining weight?
Currently, no. We list the macronutrients of the recipes, and they were factors that were included amongst the variables that the data scientists looked at. But we don't necessarily build it around that. We allow users to sort by sort of calorie counts and things, but in terms of like hitting specific health goals, it's not something that we kind of that we do any recommendation on at the moment.
And having seen all these pictures of the beautiful dishes, I think it's fair to say that all your dishes are on the healthy side. No, I didn't see a lot of fish and chips in there.
Yeah, absolutely. I guess the premise of the service is that it's, the mission statement of Mindful Chef is to make healthy eating easy. So the recipes are already like very much on the healthy end of things. No nasties in there, no refined carbs, lots of fresh vegetables. So they're generally they're generally very, very good for you anyway.
Yep. And then an interesting question: are there any plans to implement this project in Asia? So maybe back to those global expansion plans. Are there expansion plans?
There are international expansion plans, but I think Asia is a few years down the line. So we get there.
It sounds like you have a customer there already. If and when you're ready for it. That seems to be all the questions we have in Slido right now. So unless there's another one coming in the next 15 seconds, I believe we should probably round this off. And of course, Rob and I will be in the Zoom room following this when we drop off here, and happy to answer any more questions you have in that Zoom room. And I believe the presentation is also going live online. And so, of course, you can follow up with us after that as well. But thank you very much for listening. Thank you, Rob, for joining me, and see you in the Zoom room.
Perfect. Thanks, everyone.